RailClone already comes with several wooden cladding presets, but sometimes you want to create your own. The easiest way to do this is to take an existing library and modify the style to suit your own needs. The first thing you'll need for any cladding is a closed spline. The built-in styles automatically align themselves to closed splines and create an area that's large enough to fill the space. It's also worth mentioning that you might find you get better results if you reset the X form of splines before using them with RailClone. So next you need a RailClone object. Then open the library. In the built-in library, go to Architecture, Exterior, Cladding and load any of the plank cladding presets. In the library thumbnails, these look as though they have different textures, but in fact they all have the ability to choose from one of 22 built-in colour options. Once you've loaded a cladding style, you can change these materials using the option found in the parameters rollout. If you're using Corona or renderers other than V-Ray, you'll need to just disable instancing from the display rollout to enable this feature. So we know the materials are the same for all the libraries. The main difference therefore is between the plank profiles and the way in which these planks are assembled. There are over 10 styles, so for most people this is probably enough. And don't forget, you can also change the materials to use your own textures when the job requires it. If however you'd like to customize the style or create your own, keep watching. The first step to learn how any style is made in RailClone is to open the style editor and examine the graph. Fortunately for this example, it's quite straightforward. There's a node for the clipping spline, a node for the geometry, and most of the work is done by a macro designed specifically for cladding. The first thing you might want to do is to change the geometry itself. To do this, just select the segment node and choose New Geometry using the button from the Properties panel. In this case, we'll pick a simple straight-edged plank. If you've added your own materials, you might want to change the UV mapping. To do this, go to the Deform Mapping Settings and enter new values for the length, width and height. And now let's turn our attention to the macro and walk step by step through its options. So first of all, horizontal or vertical is pretty straightforward. It allows you to switch the orientation of those planks. Below that, random UVWs is really useful. It'll shuffle the UV position of each individual plank and it's great for hiding obvious texture repetition. Of course the maps you use will need to be tileable. Stepping mode is used in conjunction with the top padding value below. When this option is enabled, entering a negative value for top padding will cause alternate boards to overlap in front of their neighbours. If this mode is off, they still overlap as expected, but they're not moved in front of the neighbouring boards. Z offset does pretty much what you'd imagine. It offsets the entire cladding so that you can move it towards or away from a surface. Material allows you to parametrically change the material ID of the planks. It is primarily used for our libraries where we want to allow users to choose materials easily. If you want to create a similar setup, then this is the option for you. Plank angle rotates the planks. It's quite a smart feature though. If the rotation angle is large enough, planks will start to automatically overlap. If we swap the plank for this tapered style, we can see a limitation of the plank angle feature though. It uses the bounding box to calculate when the board should overlap. But because this is tapered, it's narrow at one end and it's calculating it slightly incorrectly. The thickness parameter is therefore used to override the size used internally to calculate this overlap. Enter the thickness here that's the size of the plank at the end you're wanting to overlap. In this case it's about 1 centimeter. Scale minimum and maximum allows you to randomize the size of the boards on the x-axis. Because we are automatically box mapping the segments, there's also no need to worry about stretched UVs. Padding allows you to adjust the spacing between the boards to either add gaps or cause them to overlap. If we change to another board profile, we can see where this might be useful. This board is designed to jigsaw together vertically. By using a negative top padding value, and don't forget with step disabled, the board will close up correctly. Moving down, the chances are you won't need to use the expand property for wooden cladding. But in rare cases where the planks are not rectilinear, you might find that the geometry doesn't quite reach the edges of the spline. The expand property fixes this by enlarging the size of the array and then cutting off anything that's outside of the splines. Closely related to clipping splines, we have the hierarchy modes, which are used to control how the cladding is created when you have several subsplines. Option 1 disables hierarchy checking, meaning each individual spline generates a unique array. Option 3 attempts to work out which splines belong to which bits of facade. It does a pretty good job, but as you can see, sometimes it's going to need a helping hand. So option 2 allows you to assign matching material IDs to the subsplines, and this tells RailClone which paths belong together. Finally, minimum last object size allows you to set a minimum size for the final plank in the array. This is useful when, as you can see here, you have very short planks at the perimeter. If you enter a value, you can be sure that no plank on the right hand side of the cladding will ever be smaller than this size. And that's it. We hope you find the built-in styles and the cladding macro useful for your work. If you have any further questions, please contact us on the forum and stay tuned for more tutorials coming very soon.